Greetings, this is Mark Anderson from Kellogg Community College, and we're going to look today at perfect square trinomials. Now, what this is going to do, it's going to allow us to make our work a little bit shorter. And you can see in the next four problems that there's going to be a pattern here, because if I remember my easy trinomial factoring, since my first term is a 1, or leading coefficient is a 1, I can say, okay, what two numbers multiply to make 4 and add to make 4? And that answer is going to be, well, that would be 2 and 2. So this would be x plus 2, which is pretty nice because you can see that 2 times 2 makes 4 and 2 plus 2 adds to 4. Let me look at the next one here. So I'm going to go, let's see, what two numbers multiply to make 36 and add to make negative 12? Oh, well, that would be 6 and 6 if both of them were negative. So here's x minus 6 and x minus 6. Well, hey, this is kind of interesting. You'll note that both of these binomials were exactly the same. I wonder why that is. Well, we have to think of square numbers. So if we think of 1 times 1, or 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on and so forth, you can see that there's actually kind of a cool pattern here, because the first term and the third term are both rootable numbers. The pattern here is called the a squared plus, or in this case minus, 2ab plus b squared pattern, which means that if the first term and last term are square rootable, if the middle term is twice the product of the two rooted numbers, you can make the problem pretty quick actually. Like 16 and 9 are both rootable numbers here. So if I make the problem 4x plus 3 and then 4x plus 3, lo and behold, that is the factored form of the problem, because 24 is double 3 times 4, which is 12. Now, here's the great thing about this. If you don't actually find this perfect square trinomial, like if you totally forgot about this pattern, you could still go ahead and do this old school style of going 16 times 9, which is going to be 144, listing all the factors of 144 and then realizing it's 12 and 12 to make a positive 24. Then if you do the whole problem out, 16x squared plus 12x plus 12x plus 9, you'll still get an answer of 4x plus 3, 4x plus 3, because you're going to find yourself using the grouping method here to get your matches, and so you do end up with 4x plus 3, 4x plus 3. So this is a problem. This is a pattern. The perfect square trinomials pattern is something that you don't actually have to memorize, but if you are quick to identify it, you're best to try to see if you can use it. Now, how to identify again the perfect square trinomial? You look to see if your first term is square rootable and your last term is square rootable. If those first and last terms are square rootable, as they were in each of these examples, then you can use the pattern or shortcut. So for our final problem here, because each of these three problems, what did they have in common? Well, what they had in common was the first term and last term were square rootable. But if you look at problem 32, you might say to yourself, well, that's not square rootable. But yeah, let's pull out a common factor. I'm going to move this up here. If I pull out a 2x, then this makes the first term 25x squared. Now the first term is square rootable. Minus 80x, and then the last term is going to be a positive 64, and that also is square rootable. And the square root of 25x squared is 5x. So this would be our first terms of the problem. And then this is going to be 8 when I take the square root of that. And since this middle term is minus, I'm going to have to put minuses there, because that would give me the negative 40 and negative 40 that add up to negative 80. So my answer is 2x times 5x minus 8 and 5x minus 8. Now you will see some answers in the back of some books write this as 5x minus 8 quantity squared. The reason why I don't do that is because in the next chapter, Module 12, we are actually going to want them separate for possible simplification, or canceling as you might say. Well, thanks for watching this little short video about perfect square trinomials. A nice little pattern to see if you remember it, but completely unnecessary if you know how to factor your easy and tricky trinomials.